Hi guys, this is Miss Santos, and the topic for today is going to be enthalpy. So enthalpy helps kind of describe a lot of reactions. In chemistry, we learned about matter and a little bit about energy. And when we look at a reaction, we're able to describe, um, you know, is it going to be a decomposition? Is it going to be a synthesis? But we can go much deeper than that. For example, the reaction we have here is photosynthesis, something that we see in plants every day. And believe it or not, just knowing the location of energy in this reaction, we're able to expand on our type of reaction here. Or at least expand on our explanation for this reaction and what's happening. Okay, but before we get to that, let's take a look at some factors that we need to recall from previous units. First thing, we need to understand what it means when energy is being released and what it means when energy is being absorbed. The first thing we need to know is when energy is being released, that means it's exiting the system. So I usually think of it that way to help remember exit means exothermic. So we'll write exothermic here. And how that looks like in a chemical reaction is that since it's exothermic and it's being released, it would be found on the right hand side of the reaction, which is our product side. Okay. And then the next one is absorbed is entering, so endothermic, and it's on the left side, which we know it's our reactants. Okay, so when we go back to this equation, our heat energy is right here, and we already know it's being absorbed, so that means it's endothermic, right? So we can write heat on this side of the equation. So it'll be heat plus carbon dioxide and water to give you glucose and oxygen. So that means that this reaction is endothermic. So we're kind of building here. So let's dig a little deeper. Once we know if something is going to be exothermic or endothermic, we're able to tell what's happening to energy in that system. For example, in an exothermic reaction, energy is released into the surroundings. And because of that, if you were to touch it, you would feel that the temperature is increasing. You feel it getting warm. That's because your hand is absorbing that energy. When it's endothermic, on the other hand, endothermic is absorbing energy. So if you were to touch it, your hand will feel really cold, and that's because energy is leaving your hand and being absorbed by the reaction. Okay, so two perfect examples. When we have, let me get my drawing tool here, and when we feel it getting hot, that's because energy is releasing, and that would mean that it is a exothermic reaction. So this is a heat pack. That's why it gets hot. That means energy is being released. Okay, energy being absorbed to the point where it feels cold is an ice pack. Okay, two things that we've used. Okay, so if we go back to this reaction, okay, we said it was endothermic. And if we go back to our slide, we said endothermic is going to feel cold. So we can say feels cold. Okay. And let's keep building. So enthalpy is something that I was discussing about, and something that goes along with entropy and in thermodynamics. So pretty much is a quantity that's or equivalent to or demonstrates or displays the total heat content of a system. And if you go more specific, if you were to, like, let's say, look up the definition, it'll just go into that it's equivalent to the internal energy of the system, so whatever energy that system has, plus the product of pressure and volume. So that's the more specific measure of it. But it's really just how much heat is in that system. And then when we look at enthalpy change, which is this delta H, okay, it's the increase or decrease in energy of a chemical reaction, which just really means the heat gain or lost by the system at constant pressure. Okay. And it's always key to remember that energy is stored on bonds. So breaking or making bonds will tell you if there's going to be an increase or decrease of energy. And really, what we have a table that actually helps, and that's table I on our reference table. And this table tells us if something's going to be endothermic or exothermic. So, for example, up here, the formation of carbon dioxide and water from CH4 and O2 is exothermic because it's negative. Okay. But when we look at, let me move up here, the formation of nitrogen monoxide, NO, is positive 182. So that's actually endothermic. If we were to flip it, meaning like we start with NO, so we're going this way on the reaction, it would actually be negative. So these standards here are pretty much given to you, so that way you don't have to calculate how much energy is being gained or released in each of these equations. Okay, so let's take a look at a practice question here. So this one, the answer has already been given to us. And it says, using table I, determine the enthalpy change for the reaction below. So when we go to table I believe I have that already in here. Is that the same? Yep. Carbon monoxide, give you carbon dioxide. That's a negative 566. So that's how we got this number here. That negative means that it's going to be exothermic, meaning it's exiting the system. So we just take the absolute value of this number and we're going to put it on the right hand side of the equation because it's exothermic. Okay. We don't have to put the negative sign. We already know because it's on the right hand side, it's negative. It's being released. If it was on the left hand side, then it would be positive, being absorbed. Okay. And that's how you rewrite the equations to show it. You could write that, or you could write heat instead of the number. And let's take a look at some more practice questions. So this question here is saying, which equation represents an endothermic reaction at 298 degree Kelvin, or exothermic reactions? So we go back to, the first one is nitrogen and oxygen gives me nitrogen monoxide. So nitrogen, oxygen, nitrogen monoxide is plus 182. So that's my enthalpy change, 182 degree, not degree Kelvin, kilojoules. So that's how much energy is being absorbed. So when we go here, because it's being absorbed, it's endothermic. Remember, anytime it's positive, endothermic. So I'm going to write endo. The next one is carbon, oxygen, carbon dioxide. Carbon, oxygen, carbon dioxide. Negative 393. Negative is exothermic. If you ever forget, I don't remember who's exo and who's endothermic. Who's exothermic. So just, I'm going to scroll down. If you scroll down, you'll see the enthalpy values are based on molar quantities represented in the equation. A minus sign indicates an exothermic reaction. So that's going to help you. Just look there and that'll give you a quick reminder. So what were we looking at? I think this one right here, right? Negative 393.5. So that's going to be exothermic. So we're going to write exo. Okay. And this one is KNO3, potassium nitrate. And let's look here. KNO3 is down here, positive 34. So That means positive is endothermic. So I'll write endo. Ammonium chloride. So NH4. Oops. Cl. So that's this one right here. It's 14.78. So again, it's positive. So that's endo. So we have 3 endothermic reactions and 1 exothermic. So again, endothermic means it was positive, energy is absorbed. Exothermic means it's negative, energy is being released. Here's the next one. So it says, given the balanced equation, which statement best describes this process? So let's take a look here. So first we want to know, is it endothermic or exothermic? Okay. Energy is not written anywhere in the system, so we have to go to that table again. So we already did it here. So we know it's endothermic, but if we have to look here, it's positive 14. So that's how we know it's going to be endothermic. So that means it can't be C or D because it's not exothermic. And then we want to know, does entropy increases or decreases? And if you guys remember from the last video, entropy means there is an increase in disorder. There's also more substances involved when entropy increases. And for this one, we only, since there's only 1 mole on this side, we only have 1. And we have 1 ion, 2 ions, 1 ion of NH4 and 1 of chlorine. So we went from 1 to 2 substances. So that means the number increases, we have more things or more substances. Entropy is also increasing. So therefore the answer has to be A. Just remember, entropy is the measure of how disordered something is. When you only have 1 thing, it's a lot easier to keep it ordered than when you have 2 things. And the last question. Which statement is true about the energy in this reaction? So this one already gives you the energy, which is on the left side. It's on our reactant side. That means it's being absorbed. And absorbed is endothermic, so it could be C or D. Can't be A or B. If it were exothermic, it'd have to be on this side. And then it says, is it absorbed or releasing energy? So you're not really looking at the equation anymore. You just have to remember what endothermic means. And endothermic means to be absorbed. So that's how we know it's not C. Because when energy is released, or when heat is released, that's going to be exothermic. So that's how we know it's not C. So the answer would be D. And again, for a lot of these questions, we actually use table I on the reference table. So that's just to summarize what we did today. We know that exothermic means energy released. Endothermic is energy absorbed. When it's exothermic, our heat or reaction or energy, it's gonna be on the product side. If it's being absorbed, then it's endothermic. It will be on the reactant side. I hope today's lesson makes sense. And if you have any questions, please feel free to reach out to me. Have a great day, you guys.